Our general form for exponential growth has our growth factor raised to an exponent. So there's our whole definition of our exponential growth. That's showing repeated multiplication. And that is multiplied by the initial amount. So here it is written out with some description. Our basic form looks like y is a times b raised to the t, right? So a is our initial amount, and then b is that growth factor, and t is whatever our time period is. Now, there's some different ways that we can describe the growth, and so the different ways we can generate what this growth factor is. So one way we can describe growth is just with a multiple. So for instance, you could say each week the amount doubles or triples or, is multiplied by 4. Here, let's consider each week the amount is multiplied by 5. So that 5 right there is our growth factor. Our form would look like y equals whatever the initial amount is times 5 raised to the t, right? And here we've defined the time as weeks, so that t would be the number of weeks. So there is the growth factor just described as a multiple. Now, I've drawn a line here because over on this side, we have two other phrases or descriptions you might see that are really the same form, right? But we may see the growth described as a percent increase or decrease, or we may see the growth described as a fraction increase or decrease. So if we have a percent increase or decrease, it might look like this. Each week there is a 5% increase or a 5% decrease. So let's look at this part right here. Let's consider our 5% increase. What I'm trying to generate is, well, what's the growth factor for that? Okay. Well, if your amount increases 5%, that means you keep your 100% and you add 5% each time. Well, that's 105%. In decimal form, that's 1.05. So you have seen this growth factor described as 1 plus the 0.05, right? That's where we get this 1.05. So if we were having a 5% increase each week, our formula would look like y equals a times 1.05 raised to the t. Now, to reach this 1.05, we did an addition, right? We did the 1 plus 0.05. But please notice that in its final form, exponential growth does not have any addition. Right? We have our initial amount, and it's being multiplied by that growth factor that's raised to the power. Okay? So we used addition to generate this. Right, but I can simplify this equation so I don't see any addition here. Now, if we had a 5% decrease, well, that means from our 100%, we took away 5%. So if we're decreasing, we're going down below 100%, our original amount each time. So that gives us a 95% growth rate. Okay, this would be a decrease. Well, that is 0.95 in its decimal form, and we're always going to use the decimal form when we're working in our equations. Now, you've also seen this written as 1 minus 0.05, right? So that's the just decimal form of 100% minus 5%. So if I were to write my formula here, I would have y is the initial amount times 0.95 raised to the t. So again, what I want you to notice is, even though I did a subtraction to reach that growth factor, my final form does not have any subtraction. Now, the percent increase or decrease actually can also be written as fractions, because remember, percents are just parts of 100. So 5% is 5 over 100. Right? So we can also see the description with fractions. Let's say you're given the description that each week the amount is increased by 1/5, or perhaps decreased by 1/5. Okay. So if I'm going to have an increase of 1/5, here's what that growth factor would look like. I would start with my original amount. All right, so that's the whole amount. And I would add 1/5 of that amount. Now, if I were to add these fractions, I'm going to get a common denominator here. 1 is 5/5. So we have 5/5 plus 1/5. That means in this case, my growth factor would be 6/5. Okay. If we're having an increase, your growth factor is going to be more than 1. We can see that all the way across. Here we were definitely increasing, right? If we multiply by 5, notice how that growth factor is more than 1, a lot more than 1 here. Okay. Here we had an increase. Notice that the growth factor is more than 1. Here for an increase of 1/5, that's equivalent to 1 plus 1/5, right? Your original amount plus 1/5. So our growth factor again is more than 1. Here we would write y equals a times 6/5 raised to the t. Okay. Now, if we have a decrease of a fractional amount, like say somebody's eating 1/5 of the pie each week or each day. So if we have a decrease of 1/5, then from your original whole amount, you're subtracting 1/5. Okay, now again, let's just get a common denominator there. 1 is 5/5. If we have 5/5 and we subtract 1/5, that means we're down to 4/5. If your growth factor is less than 1, that corresponds to a decrease. Just like we saw here, we had a growth factor that was less than 1. That was because we had a decrease. All right, so here is our growth factor then, if we're seeing a decrease of 1/5. So our equation would look like y equals a times 4/5 raised to the t. So here are 3 examples of different ways that that growth factor might be described to you. Remember, anytime we have exponential growth, so just a plain multiple, percent increase, decrease, or fraction increase, decrease, we are going to be using this general formula here. Our initial amount times the growth factor raised to t. Okay. There may be some addition involved in finding that growth factor, right? We may have to add 5%. We may have to add or subtract our fraction amount. But please notice that in its final form, it is all multiplication, right? The initial amount multiplies that growth factor to the t each time.